Welcome back to the Cisco NetAcad CCNA Enterprise Networking, Security and Automation lecture series. If you haven't seen my previous lecture series covering CCNA 1 and CCNA 2, I will leave links in the description for those playlists. I would recommend that you go through previous CCNA lectures before you move forward with this course. Today, I will be covering module number 4, which is ACL concepts. So the primary objective of this module is to explain how access control lists, also known as ACLs, are used as part of a network security policy. We will cover the purpose of ACL. We will learn about the wildcard mask in ACL, guidelines for ACL creation, and types of IPv4 ACLs. The purpose of ACLs. What is an ACL? An ACL, also known as Access Control List, is a series of iOS commands that are used to filter packets based on information found in the packet header. By default, a router does not have any ACLs configured. When an ACL is applied to an active interface, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if the packet can be forwarded. An ACL uses a sequential list of permit or deny statements known as access control entries, also known as ACEs. ACEs are commonly, however, called ACL statements in the industry. So when a network traffic passes through an interface configured with an ACL, the router compares the information within the packet against each ACE in sequential order to determine if the packet matches one of the ACEs. This process is called packet filtering. So if you haven't heard the term ACL before or never heard the access control list before, what you need to understand from this slide is that ACL is a type of packet filtering based on the packet header information. So it's a type of packet filtering. So you can look at that as like policing or traffic control system, a method of policing traffic on your network. And another thing you should learn in here is that the ACL can be number of statements. So it doesn't need to be one single statement. It's going to be multiple statements in most cases. And ACLs always perform those statements. Those are known as the access control entries in sequential order. So when a packet comes into a router with ACL configured, it's going to use the ACL packet filtering using the packet header, and it goes to a sequential list of permit or deny statements to see if this packet needed to be discarded or passed through a certain interface in a certain way based on the configuration that you set up in ACL. So again, if you never heard the term access control list or ACL ever before, and if this is the first time you ever heard the term ACL, look that as a method of policing traffic or filtering traffic or shaping network traffic. And that's what the primary purpose of ACL. So that's what you need to understand from this slide. And the next few slides, I will describe a little bit more in depth how it works as well. So there are several tasks a router can perform by using ACLs. Those include network traffic controls, either limit network traffic or increase the network traffic, and that would either increase your performance of your network or can be used to mitigate any issues that you have experienced in the past. So if you have a network that has performance issues, you can use the ACLs to limit network traffic to increase that performance so that you won't have the poor performance issues. You can also use ACLs to provide traffic flow control. So it is similar to network traffic performance mitigation, performance controls. You can also use ACL to provide basic level of security for your network access. So you can block access based on packet filtering using ACLs. You can also use ACLs to filter traffic based on traffic type. So if you have HTTP and FTP traffic going through a router that is ACL configured, you can use ACL to prevent FTP access, for example. So you can filter traffic based on that. Screen host to permit or deny access to network services. So you can actually use ACLs to prevent certain hosts from accessing your FTP server. So instead of doing this at the server level, you can do it at the router or the first hop level. So if you apply the ACL policies at the very first hop or a couple of hops in your network, you can prevent certain users and hosts from accessing your FTP server by using ACLs at the very beginning of your network, right? At the very front end of your network. So like, you can deny or prevent access to certain users and hosts either at the FTP server itself, or you can use the ACLs at the very beginning of your network if you want to prevent entire segment or sector or a host from accessing your FTP server. So it can screen, if the ACLs can be used to screen hosts to permit or deny access to the network services such as FTP. ACLs can also be used to provide priority to certain classes of network traffic. So ACLs are often used in a combination of QoS policies on networks with VoIP. So you can provide priority to data such as VoIP data that goes through your network over regular data using ACLs, as it can be used with a combination of QoS. It can improve the performance and quality of your network. Packet filtering. Packet filtering controls access to a network by analyzing the incoming and or outgoing packets and forwarding them or discarding them based on a given criteria. So ACLs can do packet filtering, right? So the packet filtering can occur at layer 3 or layer 4 level, and Cisco routers support 2 types of ACLs associated with those. Those are called standard ACLs and extended ACLs. So remember, on the right hand side, we have the OSI model. Remember, we have the physical, data, network, transport, session, presentation, application. So those are the layers of the OSI model. The ACLs operate on layer 3 and layer 4, which are network layer and the transport layer. And Cisco has these 2 types, one called the standard ACLs, which only filter at the layer 3 level using the IPv4 address in the packet. And then we also have the extended ACLs, which are ACLs that filter at the layer 3 using the source and or destination IPv4 address, but also it can filter at the layer 4 level using the TCP and UDP ports and optional protocol type information for finer controls. So Cisco routers support both layer 3 and layer 4 type filtering using ACLs. Let's look at ACL operation. ACLs define the set of rules that give added control for packet that enters inbound interfaces, packets that relay through the router, and packets that exit outbound interfaces of the router. So ACLs can be configured to apply to inbound traffic or outbound traffic. Please note, ACLs do not act on packets that originate from the router itself. So the ACLs will only impact or can have an impact on incoming and outgoing traffic, but not the packets that originate on the router itself. An inbound ACL filters packets before they are routed to the outbound interface. And an inbound ACL is efficient because it saves the overhead of routing lookups if the packet is discarded. So if a packet comes into an inbound the ACL interface, if needed to be discarded, it will automatically get discarded based on that the discard statement in the ACL control list, right? ACL. So that way that packet would not be using any resources in the router, like very minimal resources usage going to happen, because it's going to get discarded right out the gate, right? An outbound ACL filters packet after being routed regardless of the inbound interface. So the outbound ACLs, however, the packet will enter the router and it goes maybe even go through some routing processes before a check against any ACL policies. And if the packet needs to be discarded at that point, the decision will be made at the outbound side. So those are two different ways that you can apply ACLs: inbound interface or outbound interface. And also keep in mind, the ACLs do not act on the packets that originated from the router itself. It only acts on the packets that pass through the router, but not the packets that originate in the router itself. When an ACL is applied to an interface, it follows a specific operating procedure. Here are the operating steps used when traffic has entered a router interface with an inbound standard IPv4 ACL configured. So we are looking at the procedure or the steps the system would take when there is an ACL applied, IPv4 ACL is applied to an inbound interface, which is this is a standard ACL. So the router extracts the source IPv4 address from the packet header. The router starts at the top of the ACL and compares the source IPv4 address to each access control entry, also known as ACE, in a sequential order. Remember, it's always going to be in a sequential order. That's a very key piece of information. When a match is made, the router carries out the instructions, either permitting or denying the packet. And the remaining ACEs, so whatever the entries, ACL entries below it, so the access control entries below it, in the ACL, if any, are not analyzed. So as soon as the router finds a match in the ACL list, it's just basically going to disregard everything, all the other entries in that ACL list. If the source IPv4 address does not match any ACEs in the ACL, then the packet is discarded, because there is an implicit deny ACE automatically applied to all ACLs. So that's another key piece of information you should learn. If you have ACL implemented in this incoming interface in this case, and if none of the entries matches any of the packet header information, the packet will be discarded. So if the source IPv4 address does not match any ACE in the ACL in this example, the packet is discarded because there is an implicit deny ACE automatically applied to all ACLs. So remember that. The last ACE statement of an ACL is always an implicit deny that blocks all traffic. It is hidden and not displayed in the configuration. So it's by default, the last ACE statement is always going to be implicit deny. So if nothing matches at the any of the ACL statement above it, it's just going to get discarded at the very end. So please note, an ACL must have at least one permit statement. Otherwise, all traffic will be denied due to the implicit deny ACE statements. Because of the implicit denied already built into ACLs, if you don't have at least one statement that would match the traffic, all the traffic will be denied because of that implicit ACE deny statement. So remember that. There is a packet tracer file called the ACL demonstration. If you have access to this packet tracer file, please go ahead and do it. If you do not, I will try to find a copy and post to my YouTube channel and actually to my website. Then you can go ahead and download it and do them. So if you have the access, go ahead and do it. If you do not, I will try to find a copy and post to my website sanuja.com, so you can go ahead and do them. Wildcard mask in ACLs. Wildcard mask overview. A wildcard mask is similar to a subnet mask in that it uses the ANDing process to identify which bits in an IPv4 address to match. So wildcard mask is very similar to subnet mask in that it uses the ANDing. Remember AND and OS in computer science? If you don't remember, I will post a separate video later. But in wildcard mask is similar to a subnet mask. It also used the same ANDing process to identify which bits of an IPv4 to match, right? So recall how ANDing works, so you will have a better understanding of how ACLs use this. So unlike a subnet mask in which binary 1 is equal to a match and binary 0 is not a match, in a wildcard mask it is the reverse. So subnet mask is the reverse of wildcard mask. Wildcard mask is the reverse of subnet mask. You can look at that way. So unlike the subnet mask, in this case, where in subnet mask the 1 is equal to a match and the 0 is not match, wildcard mask is going to be 1 is equal to a not match and 0 is to a match. So it's going to be opposite. An IPv4 access control entry or ACE uses a 32-bit wildcard mask to determine which bits of the address to examine for each match. Wildcard mask use the following rules to match binary 1s and 0s. The wildcard mask bit 0 match all the corresponding bit values in the address. So wildcard mask bit 0 match the corresponding bit value in that address. And then the wildcard mask 1 ignores the corresponding bit value in the address. So remember, this is the opposite of a subnet mask. So wildcard mask bit of 0 match the corresponding bit value, and the wildcard mask bit of 1 ignores the corresponding bit value. So that's how it works. So here is a brief overview of wildcard mask, put it into a table. So we have an example of a wildcard mask 0, 0, 0, 0, and the last octet going to have all zeros. And here's a wildcard mask for 0, 0, 0, 63, and the last octet going to have 0, 0, and 1, 1, 1, 1, 1, 1, so on and so forth. So in here, if you look at the very top entry, I will only talk about the top entry and few entries here. You will see that all match. So match all octets because they're all matching here, right? But if you go to this one, 0, 0, 0, 15, match the first 3 octets, right? And then match the 4 leftmost bits of the last octet. Ignore the last 4 bits of the last octet because of this 1, 2, 3, 4 right here. And in this example, match the first 3 octets and then ignore the 6 leftmost bits of the last octet, match the last 2 bits of the octet. So I will not go through this table because what's going to happen is you'll be doing ACL labs a lot in this class if you're doing all the lab activities, and you will understand how exactly wildcard masks work as you go through these lectures. If you want to get a quick brief overview, and this is a good slide to pause and learn it. I will go with this one, the match the first 3 octets and ignore last octet. In that case, the last octet will be all 1. So this is an example of how the wildcard masks work. But again, this is just a brief overview. As you go through the labs, you will get a better handle of this. So there are wildcard mask types. There are wildcard to match a host. This is one of those types that assume ACL 10 needs. So in this example, assume ACL 10 needs an ACE that only permits host with IPv4 address 192.168.1.1. Remember that 0 equals a match and 1 equals ignore. To match a specific IPv4 address, a wildcard mask consisting of all zeros, example 0000, is required. So when the ACE is processed, the wildcard mask will permit only 192.168.1.1 address. The resulting ACE in the ACL 10 would be access-list. So that's the command that you will be using on Cisco iOS. access dash list, and we're going to give the access list number. In this case, ACL, we're going to use the number 10, and we're going to say permit 192.168.1.1 because that is the IP address that we would like to permit, IPv4 address, and then we're going to put space 0.0.0.0 because that is the wildcard mask. So you will have the IP address, the wildcard mask, and the permitting address going to be there is 192.168.1.1. So the complete command going to be access dash list, and the access list number is going to be in key 10. So ACL number 10, permit 192.168.1.1, and the wildcard mask right after it. So that is a wildcard mask to match a host. So there's a situation called wildcard mask to match an IPv4 subnet. So this is a different type of wildcard mask use. So ACL 10 needs an ACE access control entry that permits all hosts in the 192.168.1.0/24 network. The wildcard mask is now going to be 0.0.0.255, right? Sorry, 0.0.0.255. That stipulate the very first 3 octet must match exactly, but the 4th octet does not. See, that basically means the very first 3 octet, 1 octet, 2 octet, 3 octet. So 1, 2, 3, these 3 octet must match exactly, but the 4th octet, the very last octet where the IP address is going to be different in this network, doesn't have to match. So when processed, the wildcard mask 0.0.0.255 permits all hosts in the 192.168.1.0/24 network because it is matching the first 3 octets but not the last one. So the host could have different IP addresses. That's fine because they're in the same network. They should have the first 3 octets the same. So when processed, the wildcard mask 0.0.0.255 going to permit all of those hosts in that network. The resulting access control entry in the access control list 10 can be entered as access dash list 10, so ACL 10, permit 192.168.1.0, but this time the wildcard mask going to be 0.0.0.255 because that will satisfy all the IP addresses within this 192.168.1.0 network. So basically the IP address is going to be 192.168.1.1, so the binary looks like that, and the wildcard mask going to be 0.0.0.255. And remember, we are working with opposites. So that's what this table actually showing here. So with the permitted addresses going to be 192.168.1.0/24, all the addresses will be permitted. So that what you need to understand how the wildcard mask to match IPv4 subnet works. So this table give you an idea about that. The opposite match, right? So that's what's happening here. Another type is called the wildcard mask to match an IPv4 range. So this is another final type of wildcard mask types. So the ACL 10 in this situation needs an ACE that permits all hosts in the 192.168.16.0/24, 192.168.17.0/24, and so on and so forth networks. When processed, the wildcard mask 0.0.15.255 permits all hosts in the 192.168.16.0/24 to 192.168.31.0/24 networks. The resulting access control entry in the access control list 10 would be written as access-list 10, so ACL 10, permit 192.168.16.0, but now we're going to use the wildcard mask 0.0.15.255. Why? Because we want to permit a range of addresses between 192.168.16.0 to 192.168.31.0/24. So we need to match any networks within them. So we are matching a range of IP addresses. So in this case, it's going to be access-list 10 permit 192.168.16.0 with the wildcard mask 0.0.15.255, And why we do that? Because if you look at the table below here with the binary information on the right hand side, you can see that this wildcard mask satisfies the permission for 192.168.16.0 to 192.168.31.0 /24 network. So all the networks within this range now will be covered through this wildcard mask. Again, if you have a hard time understanding as I go through these lectures quickly, pause this video on these tables and then just look at it and you will understand it, assuming that you understand how wildcard mask work, in ACLs. Remember, it is the opposite of a subnet mask. Think wildcard mask as the opposite of a subnet mask, and that would make sense to you if you have taken my previous classes, such as the CCNA1 and CCNA2 classes. Again, if you haven't taken my previous classes, CCNA1 and CCNA2 lecture classes, please go back and watch those modules and lecture series before you move forward with this lecture, because otherwise it's going to be more confusing and harder for you to understand. So I assume that you know how the subnet masks work. So I'm telling you just to think wildcard mask as the opposite of the subnet mask, and hence by using this particular wildcard mask, we are allowing this IP range to in using this ACL. Wildcard mask calculation. So calculating wildcard mask can be challenging. So the one short method is to subtract the subnet mask from 255.255.255.255. So you can use the subnet mask of the network or the IP address, and then you can subtract that from the 255.255.255.255, because that's one method of doing it. So here are some examples of that. So assuming you want an access control entry in the access control list number 10 to permit access to all users in the 192.168.3.0/24 network. So how do you calculate that? So to calculate the wildcard mask, what you need to do is subtract the subnet mask, which is the 255.255.255.0, because that's the subnet mask of that, from 255.255.255.255. So if all octets are 255, and take that and then minus it that from this one. So this would produce the wildcard mask of 0.0.0.255. Hence the access control entry or ACE going to be access list 10 permit 192.168.3.0. And now we're going to use that calculated value of the wildcard mask we got, which is 0.0.0.255. So we calculated the wildcard mask by taking the subnet mask and minusing it by 255.255.255.255. Also, sometimes people call it COD 255, right? And that would end up with the wildcard mask. Here's another example. So assume you want an ACE in ACL 10 to permit network address for the 14 users in the subnet 192.168.3.32/28. So what are you going to do? You're going to subtract the subnet, so which is the 255.255.255.240 from the COD 255, which is a 255.255.255.255. So that will result in a wildcard mask of 0.0.0.15. So now the ACE would be access dash list 10 permit 192.168.3.32. That is a network. And then because the network subnet is this, and we're going to minus that with this from that, that gave us the 0.0.0.15, and that would be the calculated wildcard mask. Here's another example. Assume you need an ACE in ACL 10 to permit only networks 192.168.10.0 and 192.168.11.0. These two networks could be summarized as 192.168.10.0/23, which is a which has a subnet mask of 255.255.254.0. So what are you going to do now? You're going to take the COD 255s, 255.255.255.255, and you're going to subtract 255.255.254.0, which would end up giving you 0.0.1.255. So which is going to be your wildcard mask. So the ACE would be the access dash list 10 permit 192.168.10.0, because that's that. And the calculated wildcard mask, by subtracting these two, we end up with 0.0.1.255. So that's the way you can calculate wildcard mask during an exam. They will ask you to calculate this on Cisco lecture and lab exams, and make sure you know how to do this like back of your hand. They will ask you to calculate wildcard mask based on the network address, so they won't even give you the subnet. So they won't give you the subnet mask, they will give you the network address. You should know the subnet mask, and then they will ask you to calculate the wildcard mask, both on lecture exams and lab exams. And you should know that, because otherwise your access list is going to be wrong, incorrect, and your lab exam is not going to work. Wildcard mask keywords. So the Cisco IOS provide 2 keywords to identify the most common uses of wildcard masking. The 2 keywords are host and any. So Cisco IOS has the built-in support for these keywords. So when you are using ACLs, the host, that keyword is substitute for 0.0.0 mask, and this mask states that all IPv4 address bits must match to filter just one host address. So if you use the keyword host in your ACL entry in your Cisco IOS, basically what that base telling the device is that the 0.0.0 mask is entered, and this must state that all IPv4 address bits must be matched to filter just one host address. The other keyword is the any. The any keyword substitute for 255.255.255.255 mask, and this mask says that to ignore the entire IPv4 address or to accept any addresses. So that's what the any keyword would do in a Cisco iOS device. Again, I will go through them in a separate lab videos that I will be posting to my YouTube channel, where I will introduce you to some ACLs and how these keywords and ACL configuration can be done. So for now, just remember those keywords do exist. Guidelines for ACL creation. Limited number of ACLs per interface. There is a limit on the number of ACLs that can be applied on a router interface. For example, a dual stack dual stack basically means IPv4 and IPv6 configured system. A dual stack router interface can have up to 4 ACLs applied, as shown in the figure on the right hand side. So on the right hand side, you have a figure. You have 4 ACLs applied to an interface. You have 2 for the IPv4 and 2 for the IPv6. So specifically, a router interface can have an outbound, one outbound IPv4 ACL, one inbound IPv4 ACL, one inbound IPv6 ACL, and one outbound IPv6 ACL. So 2 per IPv4, 2 and 2 for IPv4 and 2 for IPv6. Note, the ACLs do not have to be configured in both directions. The number of ACLs and their direction applied to the interface will depend on the security policy of the organization. So depending on which organization you work for and how your boss wants you to apply the ACLs, the chief network engineer, you will, as a network technician, you will be applying them according to your company policy. But what really important here is there is a limit on the number of ACLs that can be applied to a router interface, and that is in a dual stack situation. Typically, it is maximum number is 4 in a dual stack situation. So remember that. ACL best practices. Using ACLs require attention to detail and great care. Mistakes can be costly in terms of downtime, troubleshooting effort, and poor network service. Basic planning is required before configuring an access control list. So here are some basic planning guidelines that you can follow. Put it into a table. So base ACLs on the organizational security policies. So likewise, I mentioned before, this will ensure you implement organizational security guidelines from the very beginning. So you don't have to go back and fix stuff too. So write out what you want the ACL to do. So this will help you avoid inadvertently creating potential access problems. So especially in a production environment, make sure that you understand what your ACL is doing before you apply it, and make sure that you have a comprehensive understanding about what network areas or network services or system services may be impacted by the ACL that you are about to apply, because that will have a horrendous effect on your current users if you are in a production environment. Use a text editor to create, edit, and save all of your ACLs. So ACL statements can be a little bit complicated sometimes, and it is error prone, especially even with senior network engineers. They often use text editors on a separate text file before enter into CLI, before enter into your router. So the easiest way to do this is to use a text editor, write out all your ACLs and make sure they are in proper correct order and there are no spelling or other mistakes. And that way it will help you create a library of also reusable ACLs as well. So not only that you can apply this to one device, you can actually use the same copy and paste to a bunch of other routers on the same network. So if you need to apply let's say 10-15 ACLs to multiple routers, well, the text editor not only going to help you reduce any errors and issues, but also make it easier for you to copy and paste it to those other routers once you enter into the first router. I do that all the time. I especially did that on my lab exams because some lab exams are only 2 hours long, and you have to really make sure every entry is correct because you don't have time to go back and fix stuff. And I was able to obtain a 4.0 GPA and 100% on almost every single lab. Like I believe my ACL lab exam was 100%, and there were students who actually almost failed the lab exam. Some people actually got 40% and failed the lab exam because they mess up their ACL. So that's why, because what I understood from speaking to my friends, and what had happened to them was they were entering those ACL entries, multiple entries, directly onto their router. Yeah, that's a bad idea, because if you made a mistake, it could actually mess up your network and you had to delete that ACL and re-enter it, and during that time a broadcast storm or something different could happen, and now you end up troubleshooting a whole bunch of issues. So that is always good to use a text editor. I was able to obtain 100% A+ on my lab exam by using a text editor, which is then get copied and pasted onto the routers you're configuring on your lab exams. The next one is to document the ACLs using the remark command. So there is a way to document what your ACL is doing. So this will help you and also the network technician. They're going to look at these entries to understand the purpose of a access control entry. Even if you created these access control lists, as you go through your corporate network, if you have hundreds of routers and switches, etc., you're going to forget what you have entered like 3 months ago, right? So if you have a problem with a router, even if you enter it like 3 months ago, you're probably not going to remember it. So that's why those remark commands are pretty important, and you can, describe what the ACL is doing. Test the ACLs on a development network before implementing them on a production network. So this will help you avoid costly errors. So if you have a production environment, if you have the ability to mimic that production environment on a simulated environment, I would do that. So this is where like EVE-NG come into play, because EVE-NG is actually a simulation as opposed to packet tracer, which is a emulation. You can use packet tracer still for most things, but EVE-NG is better for ACLs. So you can use a program like EVE-NG where you can actually build your entire corporate network and test out everything before you deploy everything out into the production environment, especially if you are in a position of network engineer. Remember, these Cisco classes, CCNA1, CCNA2, CCNA3, etc., they don't just prepare you to be a network analyst or technician. We are preparing you to be a network engineer. You are engineering the network. So eventually, with experience and knowledge and all the classes that you are doing, all the exams that you are doing by going through these classes, you become a network engineer. So remember that. So as an engineer, you can use programs like EVE to emulate your entire environment and engineer the network before you deploy into your production network, right? So that's another thing you can do. I highly recommend these guidelines for anyone who is a network technician or engineer, because this will remove a lot of headaches. Bad ACL input and bad ACL configuration can result in pain for your company and can be very costly for the troubleshooting and so because of the troubleshooting and the poor service issues, right? So keep that in mind. Types of IPv4 access control list. So I briefly described there are two types of access control list available on Cisco iOS devices. They are the standard ACLs and extended ACLs. So the standard ACLs, these permit or deny packets based only on the source IPv4 address, while the extended ACLs, remember, these permit or deny packets based on the source IP address and the destination IP address, protocol type, source and destination UDP or TCP ports and more, because extended ACL can operate on both layer 3 and layer 4 levels, right? Remember that. Numbered and named ACLs. So numbered ACLs. So the first thing we're going to look at. So ACLs numbered 1 to 99 or 1300 to 1999 are standard ACLs, while the ACLs numbered 100 to 199 or 2000 to 2699 are considered as extended ACLs. So ACL numbered 1 to 99 or 1300 to 1999 are considered standard ACLs. This will show up on your exam. So Cisco will ask you on a lecture exam, what are the ranges for the standard ACLs and what are the ranges for extended ACLs. You should know those ACL numbers. So you should know those number ranges. So if I ask you, I have an ACL number 50. Is it a standard ACL or is it an extended ACL? You should be able to tell me that. If I tell you I have an ACL numbered 120, is it a standard ACL or is it an extended ACL? You should be able to tell me that. So make sure, it's really hard to understand the concept to write this exam in this type of question. So I would recommend for CCNA3 exam, you memorize this. Memorize that the ACL numbered 1 to 99 and 1300 to 1999 are standard, while the numbered 100 to 199 and 2000 to 2699 are extended. You should memorize this because this will not only show up on your exam, this can be a good interview question. So if you are applying for a network engineer position, this can be asked during an exam as well. So this is a very key important concept. So because it's a concept that you can't quite learn it logically, I would just memorize it because it's arbitrary, right? Because somebody came up with these ACL values and we went with these type of configurations. So here's an example on the bottom of the screen of how you can figure out these things in a lab exam if you forget these values. For a lecture exam, you have to know this like off the top of your head because you won't be able to use any devices or any aids for your exams, lecture exams. But for lab exams, you can use this cheat. So how it works is you're going to go access-list And remember, Cisco iOS devices have helpful information, so you can use the question mark and press enter, and it'll give you what is an extended ACL, what is a standard ACL. Here you go. You have a list of ACL information right here. So again, for your lecture exam, memorize this. You need to know this. For your lab exam, you can use this. You can just use the question mark with an access list. There's also a type of access list called the name ACLs. So name ACLs are preferred method to use when configuring ACLs. Specifically, standard and extended ACLs can be named to provide information about the purpose of the ACL. For example, naming an extended ACL FTP-filter is far better than having a numbered ACL 100. So the IP access-list global configuration command is used to create name ACLs as shown in the bottom of your screen. So name ACLs are preferred method because it is easy for human to also read as well. So you would go IP access-list extended, and then you're going to say FTP-filter. So that's going to be a name ACL. So these names you should just have to know, and then you can enter what need to be permitted or denied based on whatever the ACL policy you are trying to configure. In this case, we are doing permit TCP, and we are permitting this, and then it's gonna say any and then equal to FTP. We are saying allow that FTP and then FTP data, and we have named the ACL conveniently so that it is easy to find on those extended ACL lists, right? So when you come back to this router and you look at your configuration, you know exactly what you have done previously. So that's what's shown on the bottom of this screen. Where to place an ACL? Every ACL should be placed where it has the greatest impact on efficiency. Remember, as a network engineer or a network technician, this is what you can. This is where you can shine. You know, the difference between a good network engineer and a bad network engineer is how you implement configuration efficiently. So every ACL should be placed where it has the greatest impact on efficiency. Extended ACLs should be located as close to as possible to the source of the traffic to be filtered, while the standard ACL should be located as close to the destination as possible. This is a super important concept. Everybody should understand where you should place the extended and standard ACLs. If I am your lab instructor and if I give you a lab exam and you implemented your ACLs correctly, but they were placed in the wrong locations, I would deduct marks. Your network may work, your ACL may work, but I will deduct some marks, because reason for that is this is the key difference between a good network technician and an engineer who understand ACL concepts versus someone who just go about memorizing a bunch of stuff and just doing your exam. So every ACL should be placed where it has the greatest impact on efficiency, because you are a good network engineer, good network technician. So extended ACL should be always placed closer to the source as possible, while the standard ACL should be located closer to the destination as possible. So in this diagram on the right hand side, we have an extended ACL that are usually placed near the source, the source, and the standard ACL we're going to place near the destination. So if you are, filtering something using a standard ACL, filtering host, right? You're going to apply. If you want to filter this host, you're going to apply on this router because it's closer to them, right? But if you are filtering something that is going to your server, so everybody try to reach this server, and what is the closest standard ACL you can apply to this server? Well, it is this hop, this R3. So standard ACL that impact this server should be applied here, but an extended ACL that should be applied right here. So this would make sense when we go through the labs actually. So for now, just remember extended ACL should be located as close to the source as possible, while the standard should be located as close to the destination as possible. So if everybody on this network is trying to reach servers on your network, which is the most cases in most corporate and network environment, any standard ACL that associated with that server should be placed the closest to that server as possible. So that's a very common use of ACLs, the standard ACLs. So that's what you need to get out of this slide. So I know it's kind of confusing when I go through these slides sometimes, but as we go through the lab demonstration in the future on my YouTube channel, you will get a much better comprehensive understanding of this. For now, just remember this is how it should be done because it's increased the efficiency, right? Standard ACLs closer to the destination, extended ACLs closer to the source. So remember that. Extended ACLs, source, standard ACL, destination. Remember that. So the next slide, I will also a little bit talk about that on a table. So here are some factors influencing ACL placement listed on the left-hand side and the explanation on the right-hand side. So the extent of organizational control. So the placement of ACL can depend on whether or not the organization has control of both the source and destination networks. So sometimes there are situations, let's say you have multiple campuses and each campus is controlled by different organization. So the placement of the ACL of your situation depend on whether or not the organization has the control of the both source and the destination. You may have the control of the source but not the destination, or you have the control of the destination but not the source, either or, right? The other situation is you need to other factor that you need to consider is the bandwidth of the network involved. So it may be desirable to filter unwanted traffic at the source to prevent transmission of bandwidth consuming traffic. So an example of this would be you have VoIP traffic and you have data traffic. However, you don't need the VoIP traffic to travel through a certain segment of your network. So you can apply your ACL right out of the gate at the VoIP telephone, whatever the telephone is connecting to, you should apply that ACL so that it's gonna get into the right networks, get filtered into the right networks before it's going through your entire network and go through other areas of your system. So bandwidth of the network can be managed using that ACL policy, because you're filtering out those bandwidth consuming traffic into different segments. You're sending it out to a different segment using that ACL, right? So that's an example of that. The other one is the ease of configuration. So it may be easier to implement an ACL at the destination, but traffic will use bandwidth unnecessarily. An extended ACL could be used on each router where the traffic originated. This would save bandwidth by filtering the traffic at the source, but it would require creating extended ACLs on multiple routers. So remember that an extended ACL could be used on each router where the traffic originated, but this would save bandwidth by filtering traffic at the source, while it would also require creating extended ACLs on multiple routers. Remember, ACLs do take up some router resources, right? So keep that in mind as well. Standard ACL placement example. In the right-hand side figure, the administrator wants to prevent traffic originating in the 192.168.10.0/24 network, which is this network, from reaching the 192.168.30.0/24 network, which is this network. So they're trying to prevent traffic originating from 192.168.10.0 from reaching the 192.168.30.0. So this should be blocked. Following the basic placement guidelines, the administrator would place a standard ACL on the router R3 because that is closer to the destination. So the standard ACL would be placed on the R3 because it is trying to prevent this network from reaching this network. So it is closer to the destination. So there are two possible interfaces on that R3 that you can apply the ACL. That includes the S011, which is this interface, and the other one is the G000, which is this interface. So on the R3, S011 interface is the inbound interface, and the standard ACL can be applied inbound on the R3 S011 interface to deny traffic from .10 network, because we are basically blocking everything on this network, right? However, it would also filter .10 traffic from the 192.168.31.0/24, which is .31 in this example network. Therefore, the standard ACL should not be placed to this interface. So if you apply this filter to S011, that would be bad because it would actually prevent this link from being accessed by this network as well. We only need to prevent this link, this side of this network, from being accessed by this network, right? So by placing it on the S011, you can see it's going to block both of these network, .30.0 and 31.0. So that's a bad idea. So on the R3 G000 interface, this should have another 0 just like that. That would be the outbound interface. The standard ACL can be applied here on the outbound interface of G000, and this will not affect the other networks that are reachable by R3. So this will not affect the other networks that are reachable by R3, because now this network won't be impacted because it is applied only to this interface. So the packet from .10 network will still be able to reach the .31 network, and this is the best interface to place the standard ACL to meet the traffic requirement. So remember that. So this is a standard ACL, and we are trying to prevent 192.168.10.0 from reaching this network. If I apply that ACL up here, it's gonna block both of these network. But instead, what we're gonna do, we're gonna apply the ACL right here. Now the traffic gonna be blocked only for this network as expected. So that is like an overview of how you can use a standard ACL. So if you have any confusing, if you have any confusion about what we have just covered, you're more than welcome to reach out to me. I am so good at ACLs. I can explain it to you like a back of my hand. You can also go back to the previous slides and, go back on this video and see how, I explain those ACL placements works. Next, we're going to look at how we can place an extended ACL, given this same example, right? So the extended ACL should be located as close to the source as possible. Remember, extended close to the source, standard close to the destination. So, however, the organization can only place the ACLs on devices that they control. Therefore, the extended ACL placement must be determined in the context of where the organization control extends. So, may not be able to place everywhere you would like to be placed based on your control. In the figure on the right hand side, for example, the company A wants to deny telnet and FTP traffic to company B's 192.168.30.0/24 network from their 192.168.11.0/24 network while permitting all other traffic. So remember, on the right hand side, the situation we have here, the company A operate this side and company B operate this side. So neither company has a control over the other guy's network. But the company A wants to deny telnet and FTP traffic to company B 192.168.30.0 network. from their 192.168.11.0/24 network. So they want to prevent any FTP or telnet traffic from company A's this network, from reaching company B's 192.168.30.0/24 network. So they want to prevent this network from reaching this network. So the same situation, but the company doesn't have the control over this. So it's a similar situation, right? Like the previous example. Now, how can we solve this? An extended ACL on R3 would accomplish the task, but the administrator does not control R3. Because remember, company A cannot control company B's infrastructure. So in this case, in addition, this solution allows unwanted traffic to cross the entire network, only to be blocked at the destination. Also, another issue with this is that the traffic still going to cross until this point, and then it's going to get blocked from accessing this. So that is also not a good placement for a extended ACL. So the solution is to place an ACL on R1 that specifies both source and destination address, because remember, extended ACL can specify both source and destination. So we're going to use that to our advantage. So there are two possible interfaces on R1 where you could apply those ACL. The one interface is the R1 S010 interface in the outbound right here. The other interface is R1 G001 interface in the inbound, which is this one. So on the R1 S010 interface in the outbound, the extended ACL can be applied outbound on the S010 interface. This solution will process all packets leaving R1, including the packets from 192.168.10.0/24. So it's going to process every packet, the packet coming from here, doesn't matter whether the packet originate at the 192.168.10.0 or whether the packet originate on 192.168.11.0 network. At the end of the day, it all going to get processed because the ACL is applied to S010, right? The other option is R1 G001 interface, which is the inbound interface, which is only applied to this side of this network system, this network infrastructure. The extended ACL can now going to have impact on only packets from that 192.168.11.0/24 networks, and that's where the ACL processing happens. Because the filter is to be limited to only those packets leaving the 192.168.11.0/24 networks, applying the extended ACL to the G001 is the best solution. So this should read G001. So there's another spelling mistake by Cisco. These are Cisco original slides, that's why I haven't modified much. So because this is only going to now filter only the network that we want to filter, this would be the best place to position that ACL. So if I was the network administrator or network technician, I would be applying the ACL right here on the G001, not on the S010 in this example. So that pretty much give you a broad overview of ACL and some details on how you can configure them on Cisco iOS devices. We also went over the two examples on standard and extended ACLs. Again, in my future videos, I will do some live lab demonstration where you will have a better understanding of how ACLs can be used in different scenarios. That would bring us to the end of this lecture, and I will go through a quick summary of what we have covered today. We learned an ACL is a series of iOS commands that can be used to filter packets based on information found in the packet header. A router does not have any ACLs configured by default, so right out of the box, the routers won't have any ACL configurations. When an ACL is applied to an interface, the router performs the additional task of evaluating all network packets that they pass through that interface to determine if the packet can be forwarded. An ACL uses a sequential list of permit or deny statements known as ACE, access control entries. And Cisco routers support two types of access control list. They are standard ACLs and extended ACLs. We learn about how an inbound ACL filter packets before they are routed to the outbound interface. So if the packet is permitted by the ACL, it is then processed for routing, while the outbound ACL filters packets after being routed regardless of the inbound interface, and then they make the determination. We learn about an IPv4 access control entry uses 32-bit wildcard mask to determine which bits of the address to examine for a match. And we learn how a wildcard mask is similar to a subnet mask in that it uses the ANDing, and or, remember, process to identify which bits in an IPv4 address to match. However, they differ in the way they match binary ones and zeros because they are opposite of each other. We look at it as opposite of each other, right? So the wildcard mask bit 0 matches the corresponding bit value in the address. Wildcard mask bit 1 ignores the corresponding bit value in the address. So it's opposite of a subnet mask, right? Think about it as opposite of a subnet mask. We learn a shortcut to calculating a wildcard mask is to subtract the subnet mask from 255.255.255.255. So you take that value to 255 and you minus that, you minus the subnet mask from it. That will give you the wildcard mask. Working with decimal representations of binary wildcard mask bits can be simplified by using the Cisco iOS keywords host and any to identify most common uses of wildcard masking. There is a limit on number of ACLs that can be applied to a router interface, and we learn ACLs do not have to be configured in both directions. The number of ACLs and their direction applied to the interface will depend on the security policy of your organization. So depending on how your network engineer and chief architects want you to apply those ACLs, or if you are the chief engineer or the network engineer, you should decide how those ACLs should be applied. We learn about the standard ACLs permit or deny packets based only on the source IPv4 address, while the extended ACLs permit or denied packets based on the source IPv4 and destination IPv4 address, protocol type, source and destination TCP or UDP port, and more. We also learn about the ACL number that I said you should memorize. Numbers 1 to 99 or 1300 to 1099 are standard, while the ACL numbers 100 to 199 or 2000 to 2699 are considered extended. You also learn name ACLs in the preferred method to use when configuring ACL, so it is easy to figure out what we are doing when you come back to that router later sometime. So we learn how important the naming conventions that you should use. We learn about specifically the standard and extended ACLs can be named to provide information about the purpose of the ACL. Every ACL should be placed where it has the greatest impact on efficiency. So whenever you deciding where to place an ACL, that should be the primary consideration, the greatest impact on efficiency. So we learn the extended ACL should be placed as close to as possible to the source of the traffic to be filtered. So this way the undesirable traffic is denied close to the source network without crossing the network infrastructure. We learned that the standard ACLs, however, should be placed as close to the destination as possible. So if the standard ACL was placed at the source of the traffic, the permit or deny will occur based on the given source address, no matter where the traffic is destined to, right? So the placement of ACL may depend on the extent of also your organizational control. So if you don't have control over the entire network that is crossing from source to destination, that may limit where you can place those ACLs, and also the bandwidth of the networks and the ease of configuration. That would be the end of this module. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions related to any of the topics we covered today, if you have any concerns of anything that I have said, you are more than welcome to reach out to me. You can leave a comment in this video or reach out to me through my website. Until next time, good luck with your exams and have a nice day.